Hello, this is Mohammad Yasir Arafat and we'll teach you mathematics here. In this mathematics, we'll start from indices. Okay? In this topic, we will discuss index notation, the basic laws, fractional and negative indices, scientific notation for large and small numbers. Let's start with index notation. So index notation defines us it is a method of representation of repeated numbers that are multiplying with each other. So here the number can be written as base and the number of repetition can be written as indices that will be placed upright with a small number. And that small number is called an exponent, index, power or order. For example, if you are multiplying 5 with itself for 4 times, and that 5 can be written as 5 power 4. And in another example, you can see that if you are multiplying b with itself for 7 times, and then number of repetition, that is 7, can be placed as index, and the b as the base. So here, index form of numbers. In this form, we have written 5, that is base, and 4, that is index. And this number can be written as in expanded form 5 multiplied by 5 multiplied by 5 multiplied by 5. So here the number of repetition that is represented before as index, and the base that is the number that is getting multiplied by itself has written as base. So after multiplying all of these value in the expanded form can be obtained as 625. That is the ended result. So let's do some examples. So in this index form, we are having 7 power 5. So we can write the 7 power 5 in the expanded form as 7 multiplied by 7 multiplied by 7 and multiplied by 7. So write the 7 for 5 times to multiply with itself. After that, you will get the result 16,807. If you are multiplying 8 power 9, if you are solving for 8 power 9, and then you will get the expanded form as 8 is getting multiplied by 8 for 9 times. After writing all of these values, you will get this result. That is 134,217,728. So in billions you will get the result. Now, for 12 power 6, the expanded form can be written as this, and the value will get you this one. That is 29,85,984. So the index form can be of algebraic expression can be written as just like we are having this picture. So in this picture, we have a is getting multiplied by a and getting multiplied by a, which is resulted as a cube, and b multiplied by b resulted as b square. So in this example, you can see 3 a's gets multiplied by itself in the first term, and it can be obtained as the result a cube. Whereas b gets multiplied by itself for 2 times, and it it retains the value of b square, the result of b square in the second term, and the subtraction sign will remain by default from the question. Now let's discuss the basic laws for the solution of index. In the first law, when the bases are same, then add their powers. So here, as we see, bases are same here with the a, and the power, that is indices, are different on each value. Like in the first term, we'll get a power m is getting multiplied by a power n, and as a result you will add m plus n by writing the base for single time. Now so here, as we see, the bases are different with the different powers. So in this case, no change will be occurred in this particular situation. Now in the second part, where the bases are different but the powers are same, so here we are discussing all the situation for the multiplication of indices. In this case, you will write the indice for the single time on the product of the bases. So let's discuss in the exercise 1, question number 1 and 2 as written here. Now in the question number 1, you will see 3 power 2 dot 3 power 4. Here this dot represents you the sign of multiplication. So in this case, you will apply the first situation, the first condition, or the first law of the multiplication. So you will write the question as 3 power 2 multiplied by 3 power 4 is equal to 3 power 2 plus 4. So here in the result you see 3 is written for single time. In this question, in this solution, 3 will be written as single time as we had discussed earlier. So 2 plus 4, that is the power, will be added with each other. In this case, 2 plus 4 will give you the result 6. So I have written the result as in the bold form, that is 3 power 6. Now in the next question, it is very different from the first one. You will see the 3 and 7, that is represented right before the exponential value. So 3 and 7 gets multiplied with each other, that is 3 into 7 will give you the 21, and a power 5 plus 6. So a power 5 plus 6, in the index you need to add the powers of both terms. So it will give you 21 into a power 11. In the next part, next question, here you will see 2 power 4 u power 3 dot vu square. Here 4 will get multiplied by 1, that is the coefficient of the second term, and u will get multiplied by u with the addition of the power, and v will be written as itself. So in here we will apply the two conditions. For the first instance, we will apply the 4 that is getting multiplied by 1. It will give you the 4 only, and first condition will be applied for u only. Here u can be written as 3 plus 2 because u are the same bases used for the both first and second terms for the multiplication, and v can written as separated. V can be separated just because of the second condition, where we found it as the different variable with the different power. So we will get the result as for u power 5 into v. Now here in this question number 4, as you see it, you will find the different variable with different power. So again, no change will be occurred, only 3 and 2 will get multiplied with each other. 3 into 2 will give you 6. So write x right before y square. So x into y square, 6x into y square. So it will be the end result. Okay. Now we have done with the demo session. Thanks for joining me. Hope we will continue for the next. Thank you.